Hello viewers, we've got some more findings for you. It turns out that there are integer angle lines that go straight through each of the ends, and with the exception of this 49 degree, which I need to get to the bottom of, these are all the parallel lines to existing parts of the geometry. So there are 5 capital N's and they've all got lines through, which I'll discuss, and then we've got some other issues. We've got this E being connected to these two E's here. All the lines on here, all the red and the blue lines and these grey lines, are out of the geometry proper. These vertical green lines are just connections that I've noticed. You can notice the 2 O's, etc. So I'll go through those, but let's just go through in detail what each of these are. So to start off with that N, that of course is part of the vesica piscis, which you discovered in the centre of the page, and this line that goes at 45 degrees almost exactly from the corner of the hexagon up to this corner of the pentagon, and if we extend that, it ends up at the K. Now what's interesting about that K, what I've just noted, is that there's a little crack on it there, and that gives me this I. So that line is terminated on the centre line of Shakespeare's, which I have here. That's that large triangle which is part of this. If you haven't analysed this, or if you're not an Oxfordian, you don't, because you won't be coming back out again. The orientation, scale, location of this are all predetermined. I haven't moved these around. This is just what comes out of the geometry. So that we've got this I then, as a result of this, you can break these off and bring that down there, and it makes a Starship Enterprise. So, and then next to it, this N, which I'd noted was not at 45. I'd seen that before, but I didn't think of it, any more of it. Well, it turns out that there's a line at exactly 49 degrees that goes from that point on the A straight down, and I terminate it on the centre line of Neue before, and it goes straight to that N. And arguably, actually, it goes to the foot of the N if you carry it on. Now, this point on the A, which is how that line is defined. It's defined as travelling at 49 degrees from that point. Well, it turns out that point is used by Kepler's triangle, which is here, and the corner of the right angle corner of Kepler's triangle is on that part of the A, so it's the same part of the A, and it also intersects the Aspley swoop at that same point on the A. So that makes me quite confident of the validity of that, and it's defined. That point is defined as where this line intersects that line across there. So I've got a nice definition of the of that point, and that travels up to that I of the H. So I claim a trinity, and that I is perfectly above that O. The green line is from the centre of this O down there, and it isn't quite in the middle. I think these green lines are just, and clearly that O is perfectly below there, but they're not part of the geometry proper. So that's those two. This sort of clips the eye. Then this one, which is the first one that I've noticed, this points to the corner of that N there, and it's defined as a 51 degree, which is parallel to our Great Pyramid here. 51 degree line from there that goes up, and again is terminated, because it's the only thing I've got on this, is terminated on the centre line of Noi before imprint, and I have a line that bisects that eye. Now you might be complaining that my red line doesn't go through the ends, because with this end business, what these lines are doing is drilling straight through the end, and this one isn't, it's out. But the reason it's out is because according to my geometry, I've got the this corner of this end, the dot there, a little bit too low, and that's because this has been set with respect to this line here, which bends up. It's been set to a point just to the right of that green there. It's on the centre line of this. So it's been set to the centre of that, and this whole lower rule has actually been set slightly too high, and it's bent. Now if I draw the line from where that dot actually is on the page, it will drill straight through there. So that's that one. And then the next one is a 45-degree line travelling from this point. So what's that point? Well, that's this here. And whilst that's quite a sort of a virtual point on the page, there's nothing on the page. Having slept a few times on this, I'm quite confident that is where it's supposed to go from, because that's quite a distance away, and an exactly 45-degree line drills straight through this, and then ends up on here, which is a new dot. That's the Aspley swoop dot, the swoop dot, and you'll see there's a little horizontal line there. This Aspley swoop dot is defined as the intersection of this 45-degree line and that horizontal, is travelling from the this point, which is where this apex is supposed to, there's an apex here that's supposed to be pointing, it's out, the apex points to round about there, which isn't perfect. This whole thing should be a little bit further to the right, as you can see from this, and that point is the corner of the 3-4-5 triangle. It's that thing there, and as you can see by the definition of that, and it's a little bit too high, and that's how we were able to determine the Aspley apex. So and yeah, the cool thing about this is that there's a gap in that S. I've already got a vertical that goes straight through it, and now I've got a horizontal, and that line goes through. There's a dot on the A here, so because this isn't this, and he doesn't do things like this. Just have a corner there or whatever. There ought to be some geometry now. Now while I've got that up, these M's which are lined up, this M here of William. The N here is bolder than this bit. This is an N, but it's also an N, and I leave that to those who are more equipped to do that kind of stuff. So there we go. So now there's this blue line. It should be a red line, but I've drawn it in blue so that because this is at 45, and that's because this N here is sympathetic to this 45, 90, 45-degree triangle. So we'd already identified that. So that line appears to go down and end up on that N. That N, I haven't put it on, but the A and the T and these two N's are roughly in line. So I didn't mention the A and the T, did I? You got once you've noticed the IO, you notice that we've got another Aleph Tav here. I think that is intentional. We should have a third somewhere now. We've got that, which has been adorned. So if we're going to start labelling this, then we should have another Alpha Omega somewhere, I would suggest. We've now got this blue line which has been detected, which is a 72 degree from the horizontal, 18 degree from the vertical, which is a pentagonal angle. It's parallel to that, which is this thing, of course, which is this angle here. It's parallel to that. So, and you may say, well, look, that blue line mark, it shouldn't really be going straight through that character. It should be clipping the two serifs. And again, it's because my calculations of where that angstrom dot is, I'm a little bit south of there. If we drew that as to what's actually on the page, it will clip the serif, or the two serifs of our E. It might actually kind of miss that as a result, but it travels between these two E's. And so, yeah, what's going on with these E's? They're almost possibly the missing right-angled isosceles triangle, but I don't have any geometry on any of these E's to be able to nail them down, really. So, you know, other than this clip here, I don't know. So I don't know how we're going to relate those. But the three E's here and this E now start looking regular in some fashion. So, right, so let's start having a look at what we then started to notice about the O's. So this O is directly above that O, and this O is definitely right above that O. So I've just stuck these green lines on, based on where either the O... I've drawn this one from the N, so that it goes straight through that one there. So I think there's an M equals Rn thing going on. And all I could do for the O in 4 is that, you know, a line directly down appears to clip the serifs of the 1. Maybe that's another IO, I don't know. And I can't find anything printable for either that O and, rather importantly, that one either. There are 8 O's. I think there are 2 groups of 4 O's. Yeah, it's quite amusing looking at English literature complaining about why Shakespeare has finished his best play with so yeah, quite funny. While we've got these 2 rules on here and the Great Pyramid and this equilateral triangle, and this thing that's bent up, I just need to point out that what we now know is that this lower rule is actually built nearly 2 millimeters too big. It's too long, and it's been set slightly too high. But it is horizontal. Now this one isn't horizontal. It's noticeably or measurably floats up by its own width. And the reason it's done that, I've realised now, is that while this one is too big, you'd expect this one to also be too big if it's come from the same factory. It's not. This upper one is a millimetre too small. And if let's just zoom in there, and that blobby thing there, which should be here, right? So it's that's slightly up from the other side. And the reason he's had to tilt it up is so that it's still in line with that. So that's what that tiny thing is. I did look very closely at both those rules. They're very raggy, because I wanted to get to the bottom of whether or not there was E on this, because it is purported that there are 2 triangles on this, one to there and one to there, which represent E minus 1 and E. Now, tangents of those values, yeah, nearly in the area, but the reason I know that E isn't there is because these must be horizontal. There's, you know, E has no place, but you shouldn't sensationalise it in terms of having access to that number, because it turns out that Johannes Kepler had the antilog of 1 in 1609, but as I say, I know that it's not there because it just doesn't fit the model, and it is a little bit sensational. This 49 now, that is a new number. That's new data into the system, if you like. I need to find out why that is at 49. And he's not made it 48 or 50, that neither of those work, or the 51. That's actually 3 degrees difference, and you have to start bending this around. You're entitled to say, or to think, that we've no room, no, there's no freedom left. It's 49 because it has to be 49. But I've learnt that there is no depth to the deviousness of Mr. John D, and so that 49 has a reason. I need to get to the bottom of that. Now, also, in terms of what's left now, so I suspect now there needs to be some more geometry around this, but we'll wait for inspiration to arrive. I've also got these 2 dots here, so there is unfortunately yet more to come, but that's certainly mopped up a lot of the page that's left. We're now down to picking which characters now on this entire page have not played some role somehow, and that's almost all of this now is playing some part in this game. Over to you, Jack.
Oh, the factories may be roaring with the boom-a-lacka, zoom-a-lacka-wee, but there isn't any roar when the clock strikes 4. Everything stops for tea.